Hello everyone, a very good evening to all of you. Good evening Neha, good evening Chetu. I appreciate your punctuality, you're always on the time everyone. That's so nice, that's so nice. Is the audio and video clear? Please confirm the audio and video once before we start the class. Rahul, good evening. Is everything clear? Can you hear me? Can you see me everyone? Okay, very good, very good, very good. So here we are into the third session of this GATE Score Booster series, and as we promised, today is the third session, and tomorrow we will have the session of the foundation engineering, right? So all of you are very excited about the foundation engineering. I have sealed it, I have logged it. Tomorrow we will be having the session of foundation only, right, everyone? And today we will try to cover the maximum portion of the geotech which is remaining, right? And today I have brought up more questions for you people, right? I have brought more questions for you people, right? All right, everyone. So let us enter into this, right? Let us enter into the first question. Let us enter into the session straight away. Now, here is the first question on your screen. Here is the first question on your screen. Start solving the question straight away. We will not waste any sort of time. Just go straight away for the question. Everyone, go for the question. Go for the question. Attempt the question, everyone. Now, many of you must be getting confused whenever you see the sheet pile. Sheet pile is never to be confused with any sort of foundation, right? It is not a foundation, right? It is something different, okay? So what it is actually, you'll be telling me, right? All right, everyone. All right, everyone. So you are telling me straight away what is the right answer for this question. I'm waiting for your replies, everyone. I'm waiting for your replies. Now, this is a good question, and the people who are into the touch of this will only be able to answer it. Anyone with the answer? Vivek, good evening. Good evening. No issues. You are not late. We have just started. This is the first question only. How many of you are able to solve this question? See, as I promised to all of you. Okay, how many of you can give the answer of it? Neha, very good. Neha, very good. I appreciate Bache. You are going absolutely right. Right on the first question, you are giving me the correct answer. All right. All right. Since all of you have seen the first question, before I start answering the question, how many of you applied the 50 number of questions yesterday which I asked you to apply? How many of you applied the 50 questions yesterday which I asked you to apply? Tell me, everyone. Tell me. How many of you applied the 50 number of questions? Or what is your number of questions which you applied yesterday? What is your number of questions which you applied yesterday? Who is going to tell me? Tell me, everyone, quickly, waiting for replies. "47 ही किया." 47 is fine. I will accept 47. But try to be 50 plus 37. Chetu, I appreciate again. Vivek, what was your number of questions? Bache, Rahul, how many questions you applied? See, as I always say, that more will be the number of questions practiced, better is going to be the All India rank, as I always say this. And again, please try to understand this thing here. I promised to you on the first day when we were applying the very simple sort of questions for the geotechnical engineering, I promised to you that we will have better and even more difficult questions on the third day and the fourth day. Now you can see the first question of today is a bit on the difficult side, and only one answer I have received so far. Very good, very good. Subject can be any, Vivek. I am not asking you to apply questions of geotech or environment or transportation or structural or my subjects only. It can be any subject, right? Chetu, see, test series is always good, but before entering into the test series, all of you should be able to apply the previous year questions. So the first priority is applying the previous year questions and then entering into the test series, because previous year questions you also have the solution for them. You also have studied the concepts related to it. So what if you are going for a good test series? No, bache, the test series are always made a bit difficult. Good test series, good institute, right? So whenever you are going for a test series, you may find that your score is a bit low in comparison to the actual score which you will be scoring, right? So never get depressed about the test series if you are scoring low. Number one. Number two, the first priority is first you apply the previous year questions and then you enter into the test series. And also, if you can apply the test series which are topic wise, that would be even better. All right. So I have discussed about the test series also now. Now, coming to today's class, as I say, as I said previously, that first day will be the easy questions, second day a bit more difficult, and third day better questions. Now, just one of you have given the answer. Just one of you have given the answer for this question. Anyone else who want to answer this? Anyone else who want to answer this? Anyone else who want to answer this? Anyone? No one? 1.6. Very good, very good, very good. Now see, before entering into the question, let me read the question. Before I start solving it, let me read the question for you people. Right. The question says a sheet pile. Now, as soon as someone is writing sheet pile in front of you, you must be able to understand what a sheet pile does. Now, I am asking it to you, Mayank, I am asking it to you, everyone, why a sheet pile is used? What is the major purpose of using a sheet pile? Please answer in the comment section immediately. Now, amendment depth of 12 meter in a homogeneous soil mass. In a homogeneous soil stratum, the coefficient of permeability of soil is this difference in the water levels between the two sides of the sheet piles is 4 meter. Is 4 meter. The flow net is constructed with 5 number of flow lines and 11 number of equipotential lines. Now please remember how many. I will highlight this with another color. What is the number of flow lines? 5 number of flow lines. What is the number of flow lines? Just have to remember this. 5 number of flow lines. What is the number of 11 number of equipotential lines? So I have highlighted it with another color. Increase the flow path to avoid quicksand. Good try, man. I'll tell you exactly why we are using this. Okay, so just have patience. Now, the quantity of the seepage up to 1 decimal place under the sheet pile. Now, see, I'm just asking you a simple question: why a sheet pile is used, and all of you are not able to answer it. Just a few of you are able to answer it. Why? Why? Mayank, you tried a very good, you gave a very good attempt to your answer, but that cannot be considered as the exact answer, right? Now, the purpose of sheet pile is not to avoid the quicksand always. The purpose of sheet pile, the primary function is to avoid the piping, the failure of the piping. Now, quicksand is one of the outcome of the piping. So I'll just conclude it by saying one line. All the quicksand failures are done by piping first, but all the pipings may not result into the quicksand. Man, please understand it. I will repeat it. All the quick cut sand conditions are done after the piping has been done. But all the piping may not end to the quicksand condition. I hope you get the difference between your answer and what is the exact answer, right? So I'll just make a diagram to make it more clear to all of you so that you can understand it more clearly. Please try to understand this, everyone. Okay. So before I start solving this particular question, let me make the diagram for it. The diagram for this particular question will include, suppose this is the level at which this is the ground level, right? At which we are making the considerations. Okay. Now, suppose this is the sheet pile under consideration. Suppose this is the sheet pile under consideration, right? This is the sheet pile under consideration. Now, different type of sheet pile, different functions of sheet pile I have already taught in the class. Those who have attended the classes of the Geotech for me, right? And those who have studied it anyway must have studied the functions of the sheet pile. Now, whenever there is sheet pile, the level has to be shown by this type of surfaces only, right? Now, this is the one level, this is the second level, right? Now, it is given that this is 4 meters. This is 4 meters. Now, whenever I consider, man, physically they are same. Physically they are same, but conceptually they are not, right? So conceptually you need to understand that, okay? All right. Anyways, see, man, if you just want to understand it more clearly, I'll just tell you that whenever there is piping, suppose what is piping? I'll just tell you. Water will always try to make a way. Suppose whenever there is such kind of condition, water will always try to make a way. I'll show you with the highlighter now. Water will always try to make a way from this side to this side, right? And such type of failure is always known as the piping, isn't it? Isn't it? But is it always necessary that as soon as this piping is formed, the quicksand condition will form and this entire thing will fail? No. The piping, when it continues for some time, when it reaches the value of I is equal to IC, when it reaches the value of I is equal to IC, then it results into the quicksand condition. Yes or no, man? Yes or no, man? Is it clear to you now? Is it clear to you now? Okay. Since it is clear to you now, I know it must have been clear to you now. I'll just complete the diagram first now. Right? I'll just complete the diagram now. What does the diagram says? We have to make the flow net. Now, how the flow net is made? How the flow net is made? Flow net is very simple. Flow net is very simple. This is how the flow net is made, right? This is how the flow net is made. So, what actually we want to do is we want to create a hindrance. We want to create a passage, a hindrance to the passage. Now, this is what I have made. This looks like a flow net now. Okay, absolutely clear now. Very good. Now, this seems like a flow net to you, everyone? This seems like a flow net to you? All right. Now, consider the question now. Now, once you have seen the diagram, you can consider the question also now. See, let us consider all the parameters one by one. What is the data given to you? In the data, the first parameter given to you is K. Now, what is K? Very good, equipotential lines. Very good, very good. Now, what is the first data given to you? This is K, and K is given to you as 10 raised to power minus 6. 10 raised to power minus 6 meter per second. Second is the value of H. Second is the value of H. Now, what is the value of H given to you? This is 4 meter. I'll just see the data first. Now, I'm talking about the data from where you may find some confusion. Some of the students may find confusion in this data, which I'm going to discuss right now. The very first data is number of flow lines. Number of flow lines. Please understand, I'll show you two things here. One is the number of flow lines. Now, number of flow lines here are given as 5. What is the number of flow lines given? 5. Now, you are going to tell me, you are going to answer it. If number of flow lines are 5, what is the number of the flow channels? Number of the flow channels. Tell me, what is the number of the flow channels? Waiting for your replies, everyone. What is the number of flow channels? If the number of flow lines is 5, what is the number of the flow channels? Very good. The number of flow channels will be 5 minus 1, that is your 4, and we represent the number of flow channels by a parameter known as NF. We represent this by NF. Is it clear to everyone? Is it clear to everyone? Right. Since this is clear to everyone, I'll come to your doubts. Chetu, I'll come to your doubt. Just let us keep ourselves to the concept only for now. Right? Now, why there is difference of one number? Why there is difference in one number? Now, this includes the boundary flow line. If I say why this is 5, this includes the boundary flow line. This is including the boundary flow line. So this includes the boundary flow line. Now, second thing, you have got the NF. Now, second thing which you need to enter here is, what is the number of equipotential lines given to you? What is the number of equipotential lines given to you? It is 11. So if the number of equipotential lines is 11, what is the number of equipotential drops? Tell me quickly, everyone. What is the number of equipotential drops? What is the number of equipotential drops? Everyone, you are going to tell me now. Tell me quickly. This is nothing but this is 11 minus 1, that is your 10, and we represent it by ND. We represent it by ND. So we have all the parameters A, H, and F, and D. We have all the parameters now. So what is the value of the Q? No man, it is 10. It is not 12, bache. It is not 12. It is going to be 10. This is why I ask the questions from you people. Please try to understand, whenever I am asking a question, please try to answer it immediately. There is no harm, there is no insult, there is no matter of shy into it. If you are typing wrong, if I see it, I will always make it correct with the correct concept. And why we are here, why you are here, why I am here, just to correct the concepts, right? So always try to make the maximum use of chat box. This is for you only. Write anything I ask to you, right? Whatever I am asking to you, write it immediately. All right. Let us proceed to the question now. Let us proceed back to the question. So, if all the parameters in this diagram is clear to you, the answer is very simple now. If all the parameters and the concept is clear to you, you can easily calculate the value of Q. It is K into H into NF by ND. Now you have all the parameters, you just have to perform the calculations using the correct units. I will never perform the calculations. The answer will come out to be 1.6. How many of you are getting the answer as 1.6? Tell me everyone. Tell me everyone. Now this 1.6 is in what? This is in the centimeter cube per second per. Now see, now once you will be done with this, I'll just tell you something. Once you will be done with this, I'll just tell you a very good concept. Once you are done with this, I'll tell you something very nice. Done? Very good also. Very good. Now, do you think, okay, all right, very good. Now, do you think once you have got all these values, once you have got this understanding of this formula, do you think this question deserves to be asked in the GATE examination? No, this does not deserve to be asked. Why this question was asked? I'll tell you. This question was asked in order to make the students confused about the units only. Please mind my words, in the GATE examination, your 10 to 20% questions you will be making wrong just because of the calculations and the units. If you are strong at the calculations and the units, mind my words, you will be scoring 10 to 20% higher. So if you really want to work on something, you really want to make your GATE scorecard high, if you really want to boost your GATE scorecard, what you need to do is you have to be an expertise in the calculations. You have to have an expertise in the calculations. If you're not having the expertise in the calculations, you won't be able to score good in the GATE at least. You may clear the examination of the engineering services, you may clear the state services, but talking about the GATE in particular, GATE demands mathematics, GATE demands calculations. My students know it already, they know it. I keep saying it in all the classes. So please, it is a humble request to all of you that please make your calculations strong. This question was asked in the GATE examination just because of these units only. Just to confuse the students in terms of the units, that from where it came. If they are asking the quantity of the seepage, why the seepage has to be in this unit? I am continuously suffering from this. Yes, you will keep suffering from this. Okay, since all of we are having this wonderful discussion of the mathematics, tell me something. What is the difference between the students studying in the IIT and the students who are studying in the private engineering colleges? Why there is an examination named as GATE? Why IITs are conducting it? Why IITs always anticipated that what is the point where the students of the private engineering colleges or other colleges will fail? They always know that it is the calculation only, mathematics only, where the students from the normal colleges will get trapped and the students of the IITs will always be passing through it. So please try to understand my point, everyone. Please try to understand. It is the mathematics, you need to work on it, you need to work on the calculation, then only you will be able to score high. I hope I was able to convey this particular thing to you, right? Anyways, let us proceed. So I am presenting the question number 2 to you people, and you have to be absolutely quick in solving it, right? So this is the question number 2. Please answer it. This is the question number 2. Please answer it. And Chetu, your doubt about I and H will get cleared in this question, right? That your doubt regarding the I or H will get cleared in this question. Don't you worry about that, right? This is why I did not explain it there, because I have to cover that concept in this question, right? So just try to answer this. Everyone. And I'm telling you again, tomorrow will be the class of the foundation engineering. Those who want to study the foundation engineering should be present in the tomorrow's class, right? With the questions, I'll be discussing the concepts also of the foundation engineering, a few concepts, and then I'll enter into the questions. Okay. So all of you just try to be present in the live class tomorrow instead of watching it recorded. I know plenty of the students are watching it recorded, but no use of watching it recorded because you cannot ask your doubts. All right, so just try to solve this question, everyone. Just try to solve this question, everyone. This is a good question again. Four. Very good. Very good. Very good. So we already have 3 answers, so I'll start solving it now. I'll read the question first as I always do, and then I'll start solving. Now, a flow net below a dam consists of 24 equipotential drops. So what is the number of equipotential drops? 24, right? So I'm highlighting it uniformly. And 7 flow channels. So channels are given directly this time, not the lines, all right? The difference between the upstream and the downstream water level is 6 meters. So this difference between the upstream, I did show you the diagram. So this difference between the upstream and the downstream water will always be there, because there is so much of energy loss when water is passing through this, right? So due to this energy loss, this level difference in the upstream and the downstream is always going to be there, right? So the length of the flow line adjacent to the toe of the dam. The length of the flow line adjacent to the toe of the dam at exit is 1 meter. The specific gravity and void ratio of the soil below the dam are this, respectively. The factor of safety against piping is asked. So we applied a few questions regarding this yesterday also. And you enjoyed applying these questions, right? So let us identify the parameters first. What are the parameters? As soon as I write ND is equal to and NF is equal. So those who are starting to solve the questions right now, those who have not solved any number of questions before, they must understand that this is the best technique. You write the values first, you write the data first, and then enter into the questions. This is always going to be better for you people, right? So this is ND. ND is given as 24 and NF is given as 7. What is the value of H given? Given as 6 meter. Now, as we tow the dam, this is given as delta L. Delta L. We call it the delta L. At the exit and the entry are the two cases. Here he is talking about the exit. So I'll mention it at the exit only. So this is 1 meter. This is the data which is given to you, right? Now, how do we calculate the delta H? How do we calculate the delta H? The calculation of delta H is very simple. The calculation of the delta H is very simple. Whenever I divide H by ND, what I will get? H is 6 and this is 24. So this is coming out to be, delta H is coming out to be what? This is coming out to be 1 by 4. Chetu, your doubt of the previous question has been covered here and it will be covered in the further step also, right? So I am just trying to establish a relationship for the factor of safety. What is the relationship for the factor of safety? It is IC. What is factor of safety? It is IC upon I exit. This is the factor of safety against piping. If you remember, I have given the exact formula for this in the class also. What is the factor of safety against piping? It is IC upon I exit. If you remember this. All right. So what is the value of IC first? Let us calculate the value of IC first. How the IC is calculated? What is the value calculation? How is the IC calculated? A very simple formula which we used yesterday. It is G minus 1 and 1 plus E. So what is the value of G given? G is given to you as 2.70, I guess. G is given to you as 2.70 and this is 0.70. So let us solve it. Right. So this is 2.70 minus 1 upon 1 0.70. So what is the value coming out to be for IC? The value of IC is coming out to be everyone. The value of IC is coming out to be 1 only. This is coming out to be 1 only. So you have got IC also, everyone. You have got IC also. Now once you have got the IC, let us calculate the value of I exit. Let us calculate the value of I exit. How the value of I exit will be covered? What is the formula for I exit? It is delta H by delta L exit. Delta H upon delta L exit. So this is what? 1 by 4 only. What is this coming out to be? This is 1 by 4 only. This is 1 by 4 only. So what is this value now? We just put the values. What is the answer? This IC is given as 1. This is given by I exit is 1 by 4. So what is the factor of safety coming out to be? F2S against piping failure. Factor of safety against piping failure is coming out to be 4. Is the calculation clear to everyone? Yes, actually, see, I'll just repeat the statement whatever I said in the previous question. GATE will always try to make you confused in the mathematics. See, basically, there are only limited number of formulas, right? Out of those formulas, he will give you certain parameters and will ask you to calculate another parameter. So GATE will give you few parameters and will ask you to calculate another parameters. So here, what we did, I did it on the same page just to make you clear about it that all the same formulas are used. There is no separate formula. So what you will do, I am just giving you a trick. I don't know if this trick will be practical for you people or not, but I am just trying to give you a trick. Whatever is the final question being asked, suppose he is asking you the final question here is about the factor of safety. So he is asking you the FOS against piping. This is being asked. How to approach such questions? I am giving you a trick for this, right? You just write whatever is being asked. FOS piping is asked, you write the formula for it. You write the formula for it. So when you write the formula for it, you will find that in some of the questions these values are directly given if it is 1 mark question. In some of the questions the value of one parameter is given and second has to be found and then the value has to be put. So what you can do, you just write this formula and then you see what data is available to calculate IC. Then what you can do, you see I exit. What is the formula of I exit and what is the available data for that? So once you will approach like this, no, you will form a sequence and likewise you will be able to make the questions more easily. I don't know if you can apply this trick, but this is what I followed when I was a aspirant. Is this clear, man? Like this, if you are solving, you will not find it as a puzzle. Okay, bache? Got it? Got it, man? All right. So we have anyone having any doubt in this particular question? No, right? Very easy to solve. We have we were supposed to calculate FOS, IC upon I exit. What is the formula for IC? IC is this. All the values are given, we calculated it. What is the formula for I exit? Delta H upon delta L. Delta is given, delta H can be calculated by H by ND, delta is given. We can calculate, right? So we are proceeding it. We are proceeding with it now. Okay. So here is the next question, please solve it. Here is the next question, please solve it. Please solve it. Please solve it, everyone. What is the Laplace continuity equation? This is what being asked here. How many of you have seen this earlier? Everyone, very good. So I'll just mention it here only. No need to write on the next page. If he is asking you for the isotropic, what happens for the isotropic? For the isotropic, the value of Kx is equal to Kz. But for an isotropic, the answer is D only. But for an isotropic, what is the case? For an isotropic, the value of Kx is not equal to Kz, right? So when this is not equal, what we do? In the same equation, we multiply this by Kx and we multiply this by Kz. Then it becomes the Laplace equation for an isotropic, right? And if you remove this Kx and Kz, if they are equal for the isotropic, this became the equation for the isotropic. I hope this is clear to everyone, right? So for an isotropic, what you have to do? You just have to multiply this by Kx and Kz. Clear, everyone? Okay, proceeding to the next question. You must be clear with this, everyone. We are proceeding to the next question. This is question number 4 for today. So just solve this question, everyone. Very easy question. We have already applied one such question. Now you will be able to solve it very easily. Now you will be able to solve it very easily. So let's go for this question. Out of the seepage analysis, now they are always asking the same type of questions only. In the chapter of seepage analysis, now they are always asking the same number of questions. Same type of questions. So just solve it and then this is very easy. Very good, man. Very good. So, what is the formula? What is the data we are having? The data is the number of flow channels and head drops. This is 4 and this is 12, respectively. If the difference in the upstream and downstream water level is 3. So this is your H, this is your NF, this is your ND, right? What is the discharge meter cube per second per meter width of a sheet pipe? K is this, right? So what is the formula for Q? The Q is nothing but here K into H into NF by ND. So what it becomes? This is 0.1 into H is your 3 meters into NF is your 4 upon 12. So this will become what? Cancel. So this is 4, this will get cancelled. So this is 0.1. This was an easy question now. Very good. I am very happy that all of you gave the right answer. This is what happens when you are applying the same question for the second time. You will always have more accuracy. Right? Alright, proceeding to the next question. Proceeding to the next question. Alright. What is the next question saying? The next question says, this is a good question now. You should apply this question very nicely and try to get me the right answer. Try to get me the right answer. Right? This is a good question. Neha is ready with the answer. Anyone else? Neha is ready with the answer. Anyone else? Vivek Raj with the answer. All right. Anyone else? Very good, all of you. Again, this question was of the day only, this unit only, because they were trying to confuse you in the units only, right? So, will be lost per day. So, they are trying to confuse you in the numbers only. Anyways, so all the parameters are given to you here. No need to get confused by this diagram. As I said, that if this diagram confuse you, please keep this thing in your mind. More will be the data given, easier is going to be the question. If the data given to you is more, the question will be easier. Just try to get this thing in your head, right? So what is the data given here? If I want to write the value of H, what is the value of H given? H is here 9.6 minus 0.6, so this is your 9 meter, 9.0 meters. Right? What is the value of NF? What is the value of NF? This NF is here is 5, right? NF here is 5 and ND. So NF is 5 and ND, these values are already given to you. These values are 8. ND is here 8. So this NF and ND is already given to you, right? Now, talking about the data of K. This K is given to you in 0.0013 mm per second. Now, how many of you can convert this into? How many of you can convert this into day? How many of you can convert this into meter per day? Convert this into meter per day. What is the value you are getting after converting into meter per day? Convert it. The value you will be getting is 0.11232 meter per day. This is the value you are getting. Okay. This is the value you are getting. Right? So you got all the values now. You got the K, H, and F, and so use the formula Q is equal to K into H into NF by ND. So what is the value you are getting? What is the value you are getting for it? The value here. What is the Q value you are getting, everyone? Tell me. What is the Q value you are getting? This Q value is 0.6318. 0.6318 meter cube per day. Meter cube per day. Per meter cube per day. Per meter. Now this is per meter. What they are asking? They are asking you for the quantity of water meter cube that will be lost per day by seepage rounded off to the nearest number. Now they are asking for the entire length. They are asking for the entire length. What is the length? Dam shown in the figure is 90 meter long. So they are asking for the entire length. So if you multiply it by 90, and see which answer is matching, it should be 57 approximately. Since we have done so many questions like this before, this is why I have done on this page only. Right? If you face any issue, any doubt into it, just let me know. I'll explain it again. Okay? All right. How many of you got this? How many of you got this? Okay. Who is going to tell me why we multiply it by 90? Because they're asking you the total seepage loss. So write it as the hint, total seepage loss. Whenever they are asking the total seepage loss, in that case, what you will do? You will calculate for entire length. You will calculate for entire length in that very case only. Right? So whenever they are asking you for total seepage loss, you will calculate for entire. I hope it is more clear now. This is the note sort of thing or a hint sort of thing for you people for the next questions. Okay. Shall I proceed to the next question, everyone? Shall I proceed to the next questions, everyone? All right. Proceeding to the next question. Proceeding to the next question. This is the next question for you people. Just try to answer it as quickly as possible. Try to answer it as quickly as possible. Okay. Answer this. Everyone, answer this. Where ND and NF are mentioned? Okay. Revati, just do this question first. Try to solve it, and then I'll go back to that question. I'll show you where it is mentioned. Okay, bache? I'll show you where it is mentioned. Just solve this question. All right. I just don't want to disturb everyone in between. So just solve this, and then I'll go back. That has to be concluded from the figure itself. Okay. That has to be mentioned in the figure itself. I'll show you how to calculate that. That means you have not. That means you have not attended the classes for it. I guess this is why you are not able to calculate it from the diagram only, right? Anyways, but I'll show to you. Neha says A. Okay. Else is ready with the answer? Who else is ready with the answer? If I get two answers, I will start solving it for you. If I get two answers, I will start solving it. Okay, we are ready with the three answers, then I'll solve it now. Now, what is the question asking? The question has said that let me read the question for you first. The coefficients of the permeability of a soil in horizontal and vertical directions are this and this respectively, right? Now, the base length of a concrete dam resting in the soil is 100 meter. When the flow net is developed for this soil with 1:25 scale factor. Now, they are using the scale factor also. What they have done, they have introduced some other concept into the single concept, and it became a difficult question for the students, right? But it isn't a difficult question actually, right? So, in the vertical direction, the reduced base length of the dam will be what? This is what they are asking. Okay, let us solve this. Now, when we start solving this one, let us write the data first. Okay. Now, what is the value of kx and ky? I'll write the data here. The value of kx is given as 3.46. What is the value of ky? The value of ky is given as here 1.5. Both the values are meter per day. Both the values are in meter per day. All right. Now, once you have the kx and ky, reduce horizontal dimension. Now, what they are asking, what is the reduced horizontal dimension? Now, who can give me the value of b? Who can give me the value of b? Anyone with the formula under root of? If you remember, I discussed this formula in the class also. How many of you remember this? I use this formula in the class also. This is kx by ky, ky by kx. This is ky by kx. So just you have all the data. What is the value of capital B? All the data you know. What is the value of capital B? What is the value of capital B? This is given as the total base. This is your 100 meters, right? The total base. Now, how many of you can get this value? B is equal to under root of this ky is 1.5. This is 3.46 and multiplied by 100. What is the value of the small b you are getting? Is the value you are getting? This is 65.84. 65.84 meters is the value you are getting. Now, what is the scale they are using? At the scale of 1:25. At the scale of 1:25, 1:25, reduced value. Reduced value. What is the reduced value? How many of you can tell me? Reduced value. How many of you have studied? ये तो पहली बार देख रहा हूँ. Formula? No, this is a good formula. This you should be knowing. Very good, very good, very good, very good, very good. Neha, Chetu, very good. So, anyways, you can see this now. I have mentioned it very clearly. So we have calculated this small b, and what we will do on the scale of this, the reduced value as per the new scale is going to be 65.84 divided by 25. So this will come out to be what? The new value 2.63 meters. So this is a very easy question for those who know the scale conversion and this formula. So straight formula based question. Very good, Chetu. So this is a straight formula based question. All right. How many of you are clear with this? Everyone clear with this? Now, this formula now, mind if you want to write it in your notes now, this formula, if you want to write it in your notes, you can write it. This is the formula. This formula is for what, bache? This formula is for what? This is the reduced horizontal dimension, right? For the transformed section. This is the reduced horizontal dimension. I will write it here only. This is the reduced horizontal dimension. This is the reduced horizontal dimension. Right, bache? Man, you should study, bache. No issues. So I've given you the formula for the transformed section. For the transformed section. So I've given you the formula also if you want to write it. Alright, bache. Shall we proceed to the next question? Very good, very good. Shall we proceed to the next question now? Alright, what is the next question? Say this. The next question. This is a common data question. So see this data first and then I will ask you the question. This is a common data question. So see this question first and then I will tell you what the question is. Then I will tell you what the question is. You have seen this data, taken this screenshot, everyone? Noted down the data. Then I'll give you the question. Then I'll give you the question. Right. Now let us see the question. This is the first question. What is the seepage loss? What is the seepage loss? What is the seepage loss? This is the first question. This is the first question for that data. If you have not seen the data, please tell me again. I'll show you the data again. I'll show you the data again. If you have not seen the data, this is a common data question, right? So solve this question. Everyone, the seepage loss. We have already discussed the formula for the seepage loss. The entire data is given to you. I'll just solve it simply. See the data, everyone. See the data again. This is the data. You have seen the question now. See the data now. See the data and solve it. What is the value of NF? What is the value of NF? NF is 4. What is the value of ND? ND is 8. What is the value of delta H? Delta H is H by ND, right? So what is the value? Right. So moving back to this, this is the question. That was the data for the question. This is the question. Now, since I have got 3 answers, I'll start solving it now. Right? Since I have got 3 answers, I'll start solving it now. This is a very easy peasy question. What does the question say? They are asking about, first of all, let us calculate the value of H. The value of H is coming out to be 10 minus 1.5 and that is your 8.5 meters. Here it is given. This is 10, this is 1.5. Right? Now, what is the value of NF and ND? The value of NF and ND, this NF is given to you as, in the diagram you can easily find it, this is given as 4 and the ND is 8. Now once you have all these formulas, the Q can be calculated by K into H into NF by ND. So what is the value coming out to be? This value should come out to be 0.38x. Yes, this is the value coming out. So make the calculations. Concept will be given by me and the calculations will be done by you. If you face any problem, ask me. K is given to you as 0.09. The scale is 0.09. So make the calculations. Make the calculations. Very good. All of you are ready with the answers now? Done with this question? Shall we proceed to the next question now? Shall we proceed to the next question now? Okay. On the same data, this is the data. On the same data, I am giving you the another question. The another question is, this is a bit good question, make it. This is a bit good question. The factor of safety against piping, against the occurrence of piping failure. Now I told you earlier also, what is the formula for factor of safety against piping? I gave you the formula. The formula was piping. This was equal to IC upon IXit. Now see, what is required for IC and what is required for IXit? Make the calculations. See what data is available and what you have to find out. So make the calculations. It is a very easy question now. All right, just make it. Now in the figure, I'll just show you all the data. Don't worry. IC by IXit. Very good, Chetu. So make it. I just gave you this formula and make the calculations. Everyone is going to solve this. Very good, Neha. Neha is ready with the answer already. Very good, Bach. What about others? Able to solve it or not? You're able to solve it or not, everyone? Tell me. You're able to solve it or not? You want to see the data? This is the data. This is the data. For this data, make the calculations. For this data, make the calculations. Make the calculations for this data. Alright, we are ready with the two answers, then I'll start solving it. We are ready with the two answers, I'll start solving it. I told you earlier also, what you will do simply is, if you are getting confused anywhere in any of the question, write down the formula of the thing what has to be calculated. What has to be calculated, the formula is IC upon IXit. Right? So this is the formula. Now, this question can be divided into two parts. What is the value of IC and what is the value of IXit? Right? So this IXit, I already told you, I am starting from IXit. You can start from IC also. So this is delta H by delta L. I asked you delta H. The formula for delta H is, I explained you earlier, this is given by the formula of H by ND. This is given by the formula of H by ND. Now what is the value of H? The value of H we just calculated in the previous step. This value was 8.5. What was the value of ND? What was the value of ND? The value of ND was, tell me, the value of ND was, we already know the value of ND, this is 8. So, this value is coming out to be 1.0625 meters. I guess this is the value. Yes, this is the value. Now, what is the value of delta L? Please see this. Delta L in the figure. If you will see the figure very clearly, if you will see the figure, this value of delta L is already given. I'll mark it with some other color so that you can see it more clearly. You will see it. If you will see it, you will easily find that the value of delta L is given to you as 3 meters. So we will go back to the question. We'll go back to the question. So delta L is given to you as 3 meters in the figure only, diagram only. So you have both the values now. Put the values, get the answer. 1.0625 divided by 3 meters. So what is the answer of the I exit you are getting? What is the value of the I exit you are getting? I exit is coming out to be 0.354. If this is the value, 0.354 is the value of the IC, what is the value of the IC? The formula of IC we have written on the screen for the n number of times now. This is G minus 1 upon 1 plus E. The value of G is given as 2.70. 2.70 minus 1, and the value of E is given as 0.8. 0.85. Yes, this is given as 0.85. Now, when you perform the calculation, the value of IC is coming out to be 0.919. 0.919. Now you have both the values. If you want to calculate the value of FOS against piping, what is the value coming out to be? The value is coming out to be IC upon I exit. So this is what your 0.35 no 0.919. So this will be, I'll just erase it, 0.919. IC upon I exit is 0.35. So what is the value coming out to be? The value will come out to be 2.60. Now this question, which seemed like a puzzle to you in the beginning, you have given the right answer for this question this time. Why? Because you are solving it for the second time. Where is the answer? This is the answer. Is this clear to everyone? Is this clear to everyone? Is this clear to everyone? Yes or no? Crystal clear. Okay, bache. Right. So you're all set to apply the next question. You're all set to apply the next question and give me the 100% correct answer. See, you will give me the 100% correct answer. How? See this. This is the next question. Apply this. And all of you will give me the right answer. I know that. All of you will give me the right answer. Okay. Chetu, solve this. Anyone with the answer? Anyone with the answer? Anyone with the answer? Man, I'm expecting the right answer this time. See, even after the entire data, even after knowing the formula, if you are getting the wrong answer now, that means you need to work on the calculations. Calculations is the key. Bhageshri, Revati, check your answer. Bhageshri's answer is only right. Rest everyone has given the wrong answer. Right? I'll just solve it. I'll try to understand it. Come on. I was expecting the right answer. Only the calculation was missing here. The unit conversion was missing here. The rest, everything is already given to you here. Come on. Say this. The seepage occurring through an earthen dam is represented by a flow net comprising of 10 equipotential drops and 20 flow channels. Now, the coefficient of permeability of the soil is this, and the head loss is 5 meters. The rate of seepage expressed in this length of the dam is through the earthen dam. So this is what you have to solve. I don't know why you failed to solve this question. This makes me a bit disappointed. You got the answer now? Yes, calculation is very tricky here. See, I'll tell you again the thing which I have told you plenty of times. I'm telling you again. GATE will judge you on some 4 to 5 parameters. First parameter is your mathematics knowledge. Second is your calculation knowledge. Third is your unit conversion knowledge. Fourth is your formula memory. If you are able to memorize the formula or not. So these are the parameters where GATE is checking, right? Anyways, so what is the value of NF? The value of NF is given as 20. The value of ND is given as 10. So value of NF and ND is already given to you, right? What is the value of H? What is the value of H? This is given to you as H. This is given to you as 5 meter. This is given to you as 5 meter. Right? Now, also the value of K is 3 mm per minute. The value of K is 3 mm per minute. If I am writing mm per minute, make the unit conversion for K. If you make the unit conversion for K, this will come out to be as, if you are trying to convert it, this is 3 upon 1000 into 60. So what it will become? It will become meter per second. Meter per second. Chetu, very good. 500 is right. Now, this is the data already given to you. You just have to make the value of Q. Q is given by K into HF into NF by MD. Entire data is given to you here. Come on, entire data is given to you. So what it will be? This will be 3 divided by 1000 into 60 into HF is 5 into NF is what? NF is given as 20 divided by 10. Make the calculations. What is the answer you are getting? What is the answer you are getting? You need not to solve it even. This is so easy. Isn't it? Solve it. Get me the answer. The answer you will be getting is 500. This is 500. Centimeter cube per second per meter. This is the value. This is very easy, by the way. Solve it, everyone. Solve it. Now tell me something. Will you be able to apply all the formulas based on this question? Tell me, will you be able to apply all the questions on this formula? Sorry, what I said? Will you be able to apply all the questions on this formula? Yes or no? Will you be able to apply all the questions on this formula? Yes, you did a mistake in the unit conversion. Right. Will you be able to apply questions on this formula? Tell me, everyone, just confirm this. Bhageshri, Vivek Raj, Rahul, Shubham. You'll be able to apply now? All right. Now, next. We are switching to the next formula. We are moving and switching to the next formula and the next concept. Please see to this. I am presenting the first question to you on the basis of the new concepts. This is where the question is. Tell me. Solve this question. Solve this question, everyone. Select the right answer. Tell me the answer of this question, everyone. I'm trying to cover the maximum syllabus of Geotech. I'm trying to cover the maximum syllabus of Geotech. I know my students will be able to answer it at very first. Bhageshri, very good. Very good. Very good, Bhageshri. All of you. Very good, Neha. Vivek Raj. Very good, Bache. Now, how do we calculate it? They are asking about the sigma z, right? Vertical stresses at depth z. So they are asking you about sigma z. How do we calculate the value of sigma z? Sigma z. How we can give the value of sigma z? Tell me. How we can give this? This can be given by. How many of you are answering this? 3 by 2 pi into. I multiply it with what? I multiply it with what? I multiply it by P by Z. P by Z. If I use, okay, who's going to tell me if I use the Z square or Z cube? This is going to be Z square only. So sigma Z is coming out to be. Sigma Z is coming out to be. Now this value is only represented with the help of a parameter named as E, and this is P by Z square. Which is the right answer now? This is the formula. Which is the right answer now? This C is the right answer. Clear, everyone? Very good. Clear with this, everyone? I've answered this already. Can you proceed to the next question now? The next question is. This is the next question. Solve it now. Next question. Solve it now. Today we are having 18 questions instead of the 14. We are having the 18 questions in the first session, the first half, and then we have the quiz of the 5 questions. So we are already on the 11th question, right? We are already on the 11th question. Keep solving it, everyone. This is a simple formula based question. Use the Bose-Einstein equation. This question was asked in the past. They are not asking right now. They are not asking questions from this particular topic right now. This question was asked in the past, but still I am having this question for you because I want you to remember this formula. I want you to remember this formula. Bhageshji, you may face problem in this question, I guess, right? And if you know the Bose-Einstein equation, you will be through it. If you know the Bose-Einstein equation, you will be through it. I'll discuss this. Chetu, I'll discuss this. I'll also discuss what questions will they be asking exactly this year, right? I will also discuss which questions they will be asking exactly this year, okay? Don't worry. But for that, you will have to stay connected in the last class, okay? Anyways, so the formula is very simple for this, right? The formula for this is, see, they are asking the vertical stresses. What are they asking? They must be asking the vertical stresses. The vertical pressure intensity, right? Kilonewton per meter square. So how do we write it? This is given by sigma z. This is given by sigma z. What is the formula for the sigma z as per the Bose-Einstein equation? Now, Q by, this is Q by z square into 3 by 2 pi. This is out of the bracket. You have to remember this. Why I'm writing this slowly? Because you can remember it with in the class only, right? So 1 upon please understand one more thing here. Please understand one more thing, that Bose equation dealt with they dealt with stresses in all the three directions: vertical stresses, horizontal stresses, both the horizontal directions, sigma x, sigma y, and they also dealt with the vertical stresses in the sigma z direction. So you can have three such formulas. You can have three such formulas: sigma z, sigma x, and sigma y. But the majority of the chances are that the question will be asked from the vertical stresses only, 99.99% times. Why this probability is this much high? Because whenever the load is coming onto a building, or whenever the load is coming into a dam, these stresses are generally the vertical stresses only, and we have to consider the vertical stresses only. We need not to worry about the horizontal stresses, because because the horizontal stresses generally do not lead to the failure, right? Anyways, so this is 3 by 2 pi, and it will be into 1 upon 1 plus r by, this is r. I'll just try to make it more clear. This is r by z. Now, what is this r? What is this z? In order to understand this, you need to have the full knowledge of the entire Bose equation. But for now, what is easy for you is to just understand the parameters and put the values. Right? Now, what are the parameters given to you? The value of q. I'll just take you back here. The value of q. This is the value of q. Right? Now, at a point 6.0 meter below, 4 meter away from the load will be, right? So I'll just mention you the parameters, whatever the values are given. The value of q here, the value of q is given as your 25 kilonewton, right? 25 kilonewton. That's value of z is 6 meter, I guess. Yes, 6 meter. The value of r is your 4 meters. So you have all the values now. Just put the value and get the answer. The sigma that will come out to be 0.132 kilopascal. Alright, Bhageshri. Alright, bache. So those who are those who have not understood the Bose equation so far can do what? They can just remember the equation and put the understand the formulas for the variables, right? If you understand the formulas, understand the variables, once they are giving in the question, what you can easily put the values. But for now, what I have seen, GATE is not asking the questions on the Bose equation from so many years, right? They are not asking the question from this equation from so many years. All right. So this is the answer. Everyone must have seen this. All right. Now this is the next question. Before I proceed to the next question, I'll answer the doubt of the Chetu. Chetu, what he asked was, sir, what is the difficulty level of the IIT Kharagpur? See, I'll tell you my opinion, right? So things may vary. Things may vary. This is a disclaimer which I'm giving you. Things may vary, but for now, I'm just giving you my opinion. In my opinion, please try to understand. IIT Kharagpur has a very strong department of the transportation engineering, right? When I visited the department and met the members out there, I realized that they really do have a strong transportation department. So I'm generally expecting them to ask more number of questions from the transportation engineering also. So try to make the very easy subject. Transportation is a very easy subject. So try to make the transportation engineering very strong, because I am expecting around 11 or maybe 10, 9, 10 marks out of the transportation engineering, right? So this is one about the IT Kharagpur. Second, the difficulty level is going to be a bit high. Why? Because whenever you will see the questions of the IIT Kharagpur, no, they have always given a bit difficult type of the questions. Why? Because they always try to introduce some latest techniques into it, right? I just remember when I went for some discussions on some conferences, no, at that time, like suppose we are considering the students of the bachelor's. no one asked the question from the FEM or the finite element method from the students of the BTech. They generally are being asked from the students of the masters or the PhD or the research scholars, right? But students of the IIT Kharagpur and the students of which were in aspirants in the interviews were already known of the FEM and the finite element method. They were being taught the FEM. So what I observed was that they are more involved in the mathematics also, right? So the question may seem difficult to you whenever they are introducing some of the other part of the mathematics. So this is it about this is it for now. We will enter into the next question. But remember, two things I have concluded for now. One, the questions will be more formula based, more complicated type, and will be more from the transportation. These are the two things I have told for now. Okay. Anyways, let us proceed. This is the next question. This is the next question. Tell me. This is the next question. Tell me. Tell me. No? You are telling it wrong, everyone? Hmm. Tell me. I want you to answer this. D. Why? Everyone has answered the same. Why? Why everyone has answered the D? How do you know that? That D is the right answer? Tell me. How do you know D is the right answer? Why not zero? Why not maximum and zero? Why not maximum and minimum? Anyone? Alright, I'll just give you the right explanation for it. Please understand this. A rigid footing, no? I'll just tell you about the rigid footing. A few things I'll tell you. Suppose this is a rigid footing. This is a rigid footing, right? Now, in a rigid footing, what happens is, when it settles down, it settles down uniformly. It settles down uniform. This is concept number one. Concept number two, when it is settling down, how it settles? The contact pressure is non-uniform. The contact pressure is non-uniform. How? The contact pressure is formed like this. This is the contact pressure. So, how the contact pressure is formed? The contact pressure is non-uniform. It is non-uniform in such a way. That it is maximum at edges. It is maximum at edges and minimum at center. It is minimum at center. So what was the question? This is the concept. Now we will relate the question with the concept. This is the concept. We will relate the question with the concept. The question is rigid footing resting on a clay at the center and the edges respectively. So center we have the minimum, edges we have the maximum. Is this clear to everyone that D is the right answer? Is this clear to everyone why D is the right answer? Alright, we will proceed to the question number 13 of the day. 13 question of the day. Please answer it. Question number 13 of the day. Please answer it. Answer this, everyone. Tell me, everyone. Waiting for replies. Tell me, everyone. Waiting for your replies. We have already got one answer from Vivek Raj, and Vivek Raj says the right answer is C. What about others? This is from the extension of the Bose-Einstein equation. Very good. Very good. See, what is the concept used here? Please understand. If you remember the Bose-Einstein equation, what was it? The Bose-Einstein equation says that sigma z is equal to sigma z is equated to 2q dash upon pi z. So what we can make, making all other things constant, we can get that sigma z is inversely proportional to z. We can conclude this, everyone. We can conclude this. Yes, we can conclude this or not? Yes, sir, we can conclude this. Once we can conclude this, what we have? Please try to understand. Once we can conclude this, what we have? We have that sigma z at 2 meter depth. Sigma z, right here only, sigma z at 2 meter depth divided by sigma z at 4 meter depth. What is the value coming out to be? What is the value coming out to be? This is 4 by 2 and this is 2.0, that is your C. That is your C. This is a very easy question. Now, what the question is demanding? The question is demanding a uniformly distributed line load of 800 km. This data is just to confuse you. See, now, one thing is also a doubt of the students are when to know and how to know that what data is given to confuse. Please understand. If this was a 2-mark question, this data would have been used, the solution would have not been this easy. Since this is a 1-mark question, please try to understand. If a 1-mark question is involving so much of calculations, you have to make a guess that there is something which you are missing. There is some formula you are missing. There is some concept which you are missing, right? So always try to understand whenever there is a 1-mark question, that will always have some trick. And this is the trick for this question. Is it clear to everyone? Shall we proceed to the next question? All right. The question number 14 for the day. This is the question number 14 for the day. Just solve it. Solve it. Question number 14 for the day. I just gave you the concept. I just gave you the concept. Check your answer, Chetu. Check your answer. Check your answer. Bhageshri, absolutely right. Absolutely right, Bhageshri. Vivek Raj, very good. See, Bachi, what is this diagram representing? First of all, please try to understand this diagram. This sort of diagram he may give you again also. What is it representing? In this diagram, no, we are having a few things. In this diagram, we are having a few things which you should be knowing. If I consider this part, this part, this shaded part is known as what? Axis or center? I am explaining this, Bache. This edges is known as this part, shaded part is known as what? Edges. Now, whenever this diagram is confining, to a particular place, that means the last arrow is very small, or there is no arrow in the last. What does it mean? It means that this value has become 0. This value has become 0. And if you are having a bigger arrow in the center, this means this is the maximum value. Now, when a rigid footing is on the granular soil, we get the edges as the 0 and center as the maximum. So this value is corresponding to the A. Is this clear to everyone? Is this clear to everyone? Is this clear to everyone? Clear to everyone? Shall we proceed to the next question? Shall we proceed to the next question, everyone? All right. Now this is the next question. Question number 15 of the day. Question number. Now this will make you clear. This concept will make you everything clear. This diagram will make you everything clear, right? Chetu, I will explain all the options here. Don't worry. I will explain all the options here. Right? I know this needs an explanation. This is why I have included this question also. But you just give it a try first. You just give it a try and then I will explain. Okay, you give it a try first and then I will explain. Try to solve it. Give it a try, everyone. Anyone? Anyone with the concept? All right, I'll just tell you, everyone. Just try to understand this. Everyone. The right answer for this is what? The right answer for this is okay. Let us do one by one. And you will put a thumbs up after every clearing of the concept, right? So let us consider the first. Now, when I consider the first case, this is the first case. In this case, what we are having, consider the edges. On the edges, we are having the 0 value, and at the center, we are having the maximum value. Now, this case we just discussed. Where it happens? This happens when, please understand, this happens when a rigid footing, is on the granular soil. When I consider the granular soil, what does it mean? It means the cohesive soil or the cohesionless soil? When I say the granular soil, it means the cohesive soil or the cohesionless soil? Tell me, who is telling me? When I say the granular soil, it means the cohesive soil or the cohesionless soil? Tell me. Cohesionless? Very good. That means sand, grain, that Okay. Now, so this belongs to C. This belongs to C. This belongs to C. Or I can write this as, let us write this as first. Let us write this as first. This is second. This is third. And this is fourth. Now, so A belongs to, I'll write here. I'll keep writing here. A belongs to third. This is clear to everyone? This is clear to everyone? Now, let us consider the B part. In the B, what we are having, these are the edges. On the edges, we are having the maximum value. On the center, we are having the minimum value. Now, this is a case of which? This is which case? This is which case? Now, this is which case? Out of 1, 2, and 4. This is which case? This is which case? This is your second case. Rigid footing on the cohesive soil of the clay. So this is your B is corresponding to 2. Now let us enter into the C. On the C, if you are seeing, what is the value? What is the value of the C? What does it mean? What does it mean? What is the meaning of this? This is seeming the same. This is seeming the same. But this is representing the flexible footing. Why? Why this is representing the flexible footing? Why this is representing the flexible footing? Who's going to tell me? This is representing the flexible footing. Tell me. When the flexible footing on the cohesionless soil, please understand, when the flexible footing is on the cohesionless soil, it will undergo non-uniform settlement. There are 2 points which I will be writing. One is the settlement. One is the settlement. This settlement is going to be uniform or non-uniform. This is going to be non-uniform. The contact pressure and the contact pressure is going to be, this contact pressure is going to be uniform. Very good. This is going to be uniform. Right? So we can write that with the C, it will be going, who will be going? It will be 4, and with the D, it will be 1. Is it clear to everyone? Very good, Bhagesh, very good. Is it clear to everyone now? Cleared all your doubts? Have you cleared all your doubts, Bache? Shall we proceed to the next part, next question? Shall we proceed to the next question? All right. So let us see the next question. Let us see the next question. The question number 16 for the day. Solve it. The question number 16 for the day. Solve it, everyone. The question number 16 for the day. Okay, Chattu. Okay, bache. Now make the question number 16 for the day. See, in these type of questions, now when there is very small decimal difference, you have to be very specific with the calculations. And you know, rounding off, I in the very first class I told you what is rounding off. The rounding off has to be very specific in these questions, right? So this is C and this is D. This is just a typing mistake by the typist, right? Typist made this mistake anyways. So this is C and this is D. All of you have given the different answers. Now which one should I consider? Very good, Bhagesh, very good. Now I'll just tell you what is the correct answer for this. Now this Q value can be calculated by what? Q is already given. This is 700 kilonewton. 700 kilonewton. What is the value of Z? Z is given to you as 2 meters. And this R is given to you as 1 meter. Now what is the value of sigma Z? The value of sigma Z is given by this Q by Z square into 3 by 2 pi. You have all the data from here? Yes or no? You have all the data from here? Yes, you have. Now, 1 upon 1 plus R by Z square. This is the formula you already have. This is the formula you already have, isn't it? You have this formula, put the values. Put all the values. You will be getting the answer as 47.8 kilometer, right? Now tell me something, this is kilopascal, right? Tell me something, do you think this question should have been asked? Do you think this question should have been asked? But they still asked this question, why? They still asked this question, why? Because of the calculations only. Now in the GATE you will find in almost all the subjects that there are a number of the questions which are asked for the calculation purposes only, right? So if you are not strong at the calculations, you are not good at the calculations, you won't be able to score good. I am telling this thing again and again. Testing concepts, and rather than testing the concept, Chetu, they are testing your calculations. Anyways, let us proceed to the question number 17 for today. Everyone is going to answer this. Everyone is going to answer this. Everyone is going to answer this question. This is a 2-mark question, and free. These 2 marks are for free. The question has been repeated. The question has been repeated. What is it representing? The question has been repeated. So I have given you the entire concept of this. Now I want the 100% accuracy when solving the questions, right? Okay. So what is the right answer? Now this is representing the rigid footing on a saturated clay. Why? Because you have maximum at the edges and minimum at the center, and the settlement is also shown to you that the settlement is what? The settlement is uniform and the contact pressure is non-uniform in such a way that it is more at the edges and less at the center. Nikhil, Bache, I guess you just joined. Since you have joined right now, you did not know the concept. If you will watch this only, this video only now, Bache, you will be able to answer it very correctly. Okay? Because I have discussed this concept very clearly. So try to be present in the class daily so that you can understand everything. Okay, beta? Alright, so everyone is getting the concept. I'll just mention it again. For a rigid footing, I will mention it again. For a rigid footing, there are 2 things to be considered for the rigid and flexible both type of footings. One is your settlement. So for the rigid footing, the settlement is what? Uniform or non-uniform? So settlement is uniform. As far as the contact pressure is considered, for the rigid footing. This becomes the non-uniform. This becomes the non-uniform. All right, everyone. So contact pressure is non-uniform in such a way that it is maximum at the edges. At edges, it is maximum. At center, it is minimum. All right. I have again written the entire concept for you, bache. I have written the entire concept for you again. All right. So I hope it is clear to everyone. The crystal clear to everyone, right? Let us proceed to the question number 18 of the day. Today we have applied 4 more questions. Right? So let us enter into the question number 18 for the day. Alright, everyone? Let us go. This is the question number 18. Who is going to solve this for me? Who's going to solve this for me? This is a very good question, very good conceptual question. Only those students will be able to solve those who are good at concepts. Otherwise, I will explain this. And after this, we will start the live quiz. This is the last question in the question series. Then we will start the live quiz. All right? And then we will start the live quiz. All right, everyone. Waiting for your answers. This is a good question. I'm telling you, this is a good question. Now check your answer. Man, check your answer, bache. This seems wrong to me at least. This is not even in the options, man. Check it. Vivek Raj, this seems right to me. This seems right to me. Let us see, let us see. Now, see, there are 2 ways of doing it. One is you make it directly with the help of the formula. If you are making it directly with the help of the formula, it will become very easy. But if you really want to understand the concept, you have to understand the diagram, right? So I'll just give you both the ways. I'll give you both the ways. Now, let us start solving it. First is the total load. You have to calculate the, what is the calculation required? The calculation is for the total load. The total load is represented by Q, right? And this is given by 1 into 2. This is given by 1 into 2 into 150. So this becomes your 300 kilometer, right? If this is the load we are having, what is the value of the B? B is 1 meter, L is 2 meter, and Z is again 1 meter. This is the data already given to us, right? Yes, this is the data given to us. Now stress is what? Stress is given by load upon dispersed area. Now the entire game here is about the dispersed area only. The entire game here is about the dispersed area only. So what is the load? This is 300 divided by, what is the dispersed area? The dispersed area here is, who's going to tell me what is the dispersed area? This is given by, this is the value of Q. This is given by V plus Z into L plus Z. So this is the formula. If you want to remember it for future, this is the formula. Now, what are the values coming out to be? This is this value is coming out to be Now this formula is for what? How many of you are getting this? When you put the values, what is the answer? This is 300. B is 1 plus 1. This is 2 plus 1. So what is the answer you are getting? 300 divided by 1. This will become 2 into 3. So this is 6. So this will become 50. How many of you got this answer? Now this is the calculation as per the formula only. This is the calculation as per the formula. This is the calculation as per the formula only, alright? Now, once you are done with this, I'll show you the diagram also. I will show you what is the meaning of the one horizontal to two vertical and that system. No, I'll show you. Alright. So, let us move to the next page. How the distribution has to be, or the dispersion of the load can be shown. Suppose this is the putting under consideration. Bhageshri, I'll explain, don't worry. Suppose this is the putting under consideration, right? Now there is some load being applied to this. Let us consider this as Q, right? Some Q is acting on it. Now, I'll explain that for you, Bhageshri, again. Understand the diagram and then you will be able to understand it more, right? So if I consider the value of B, what is the value of B? This is the value of the B, right? This is the B. This is what I have seen. I have shown you. Now, what happens when this Q load is dispersing under the ground? When this Q load is dispersing under the ground, it disperses in such a way that it goes in this direction also. This is not that thing that it will be acting only under the footing. There has to be some other dispersion also, and I will show that dispersion with the blue ink, blue color. Now, this gets dispersed like this also. This gets dispersed like this also. Now, this dispersion is given in such a way that if this is 1, this is 2. So, this is the dispersion. Now, this particular thing is also only what? Your depth. This is your Z. This is your Z. This is what your dispersion. Now, if this is 1:2, can I say that this particular thing is 0.5 times of Z? Yes or no? This is your B, right? And this is again what? Your 0.5 times of Z. Because this becomes 1/2. This becomes 1/2. Is this clear now? Are you getting this, Bhageshri, this time? Now, this becomes 0.5Z, B plus 0.5Z. So, what it will become? This entire width, where the load is distributed, will become B plus Z. B plus Z, right? So, this becomes your B plus Z, where the load is getting distributed. Now, similarly, see, what is the value? What is the formula for the stress? The formula for the stress is load upon the area. So area is what? Your one side, that is your B plus Z, and similarly on the other side also, that is your L plus Z. So this becomes your Q upon L plus Z, and this is what I have written. Is this clear now? Everyone? Is this clear now? With the help of the diagram also I have explained you. With the help of the diagram also I have explained you. Clear now, bache? Clear? Everyone? Will you be able to do such questions now? Will you be able to do such questions now? Okay, let us enter into the quiz now. See, today I obtained more questions for you, but again, you people are so quick in understanding. Even we are able to solve more questions in less time today. Why? Because your concepts are more clear now. Now only quiz is left. Remembering formula is enough for this. Remembering formula is enough for this. If you remember this formula, this is enough. But but I will add something to it. This formula is only valid when the distribution is in such a way that for two vertical we have one horizontal. If this situation changes, suppose it becomes 1 by 3, suppose it becomes 1 and 3, what will happen then? This will become 0.33z, this will become 0.33z, and this will become b plus 0.66z. Is that clear, Chatu? Is that clear? Shall we enter into the quiz now? Shall we enter into the quiz now? Okay. Now I will start the live quiz questions. Now I will start the live quiz questions for you. Right. What are the live quiz questions for today? This is the first question. Very easy question. This is the first question, the very easy question. Every one of you should be able to answer it. Every one of you should be able to answer it. Give me the right answer. Give me the right answer. Now this is a check of your concepts. And you failed. This is a check of your concepts. Everyone is wrong. Okay, I'll tell you the answer for this. Please try to understand. This is a conceptual question. Anyone who wants to try it still? Alright, I'll just explain it. Suppose, yes, suppose this is a ground surface and this is a dam body constructed over it, right? This is a dam body constructed over it. Here we are having the water, right? And here also we are having the water. Now, what will happen if I want to make a flow net? Deepchand has joined. Deepchand, I have mentioned this clearly in the notes, right? I have mentioned this clearly in the notes. What will happen? This water will have a tendency. This water will have a tendency to flow from here. It will make a such diagram. Every one of you know this. Now, whatever is this formation, the topmost line. Now, this flow can be like this, and the flow can be like this also. I will show you another things of the flow also. The flow can be like this also. This can be the flow, right? This can be the flow. This can be the flow, right? This can be the flow. Yes or no? If this is the flow now, in this flow, what will happen? We will always have a topmost line. Suppose this line here. This line here is the topmost line. Suppose this line is the topmost line. Now this topmost line is known as the phreatic line. This topmost line is known as the phreatic line. Now, what is the speciality of this phreatic line? The speciality of the phreatic line is that below the phreatic line, that is, I will highlight the portion. Below the phreatic line, everywhere in this yellow shaded portion, what we will have? Below the phreatic line, everywhere in this yellow shaded portion, the soil is saturated. The soil is saturated. Here, this is the saturated soil. And at any point above this, line, I will erase the earlier lines. Right. Now, at any point above the phreatic line, suppose this is the phreatic line, any point here, above the phreatic line, we have the unsaturated soil. So, what is the speciality of this phreatic line? On this phreatic line, on the line, I am using the term on the line or along the line. On the line or along the line. The pressure head. Now, please understand, since all the water content is present below it, all the water of the saturated soil or saturated clay is present below it. So, there is no water to be, it is assumed that there is no water present on the phreatic line. Above this, there is no water. So, on the phreatic line, suppose there is no water on this hand. What will be the pressure head on this hand? Suppose there is no water above this hand. What will be the pressure head on this hand? Who is going to tell me? What will be the pressure head on this hand? If there is no water above it, tell me clearly, everyone. Quickly. What will be the value? Tell me. 0? Obviously 0. Right? So, on the phreatic line or along the phreatic line, the value of the pressure head is 0. Now, if I consider, very good all of you, if I consider any point below this, suppose this is the point A, the pressure head, suppose this is the hand, above this no water, below this water, any point here or here, this point A, the pressure head will be greater than 0. Below the line, which line? Phreatic line, head is greater than 0. Is this concept clear to everyone? Is this point clear to everyone? Ekdam clear, sir. Shall we move to the next question now? Okay, moving to the next question. All right, the next question is, this is the next question. Answer this question. True or false? True or false? If you have cleared your concept, you will be able to answer this. How true? Tell me. Water pressure is atmospheric at all points. Water pressure is atmospheric. Arey Baba, understand this again. This is heat traps you. This is how heat traps you. Consider this. This is the phreatic line, right? Please answer this, everyone. Please answer this. If Arey Baba, that is Chatu, that 0 is what? 0 is the pressure head, right? And what they are asking? They are asking about the water pressure. They are asking about the water pressure. Now, please understand. If I consider this point, I will use blue ink now. If I consider this point, this is point A, this is point B, this is point C. Point A, point B, point C. Which of these points have the same elevation? No points. Point A, point B, point C are not having the same elevations. Since point A, point B, point C are not having the same elevations, how the water pressure can be same? On the point B, this is under the soil, this is under the surface, this is under the water. This is even lower. So please try to understand, this is a line which separates the saturated and unsaturated. Anything below this will be fully saturated. Anything above this, unsaturated. Now, unsaturated does not mean it is a dry. Unsaturated does not mean it is dry. It may have some water head here. It may have some different water head here. It may have some different water head here. And even if it is different, it will never be atmospheric pressure. It will never be atmospheric pressure. Can you see atmospheric pressure at any of these points? Tell me. Can you see atmospheric pressure at any of these points? Can you see atmospheric pressure at any of these points? Tell me. So just publish this diagram into your mind. Publish this diagram into your mind. Then only you will be able to answer this. Right? There is no atmospheric pressure. So what they are answering, they are asking water pressure is atmospheric at all points on a phreatic line. No, this is false. Phreatic line is therefore an equipotential line. If this was an equipotential line, there was no need of giving it a different name. This is not an equipotential line. Is it clear to everyone? Shall I proceed to the next conceptual question? Shall I proceed to the next conceptual question? Yes, there was a trap in the question. Okay, the next question is, this is the next question. This is the next question. Tell me. I'll just show you. This is the gate previous year question only. All these questions are the gate previous year questions only. I have not made these questions at my home. Okay, bache? So this is typically the gate content. In the 1 mark, they may ask anything. So ESC and gate both are same for 1 mark, right? So these are the equipotential lines and this flow lines and equipotential lines in the flow net are orthogonal to each other. Yes, true. All right, bache, man, got your doubt cleared? Shall I proceed to the next question? So the next question for this is this. There we have the next question. Okay, bache? This is the next question. Solve this question. See, they have asked a formula directly. They've asked a formula directly. Now, those who have attended the classes should be knowing this. बेटा स्ट्रॉन्ग कैसे करें? क्लासेस लगाओ, कॉन्सेप्चुअल क्लासेस, थ्योरी क्लासेस लगाओ, तभी स्ट्रॉन्ग होगा बेटा, और कुछ नहीं इसमें कर सकते हम। या फिर क्वेश्चंस लगाते रहो, क्वेश्चंस की वीडियोस देखते रहो इस तरीके से, है ना। क्वेश्चंस लगाने से भी कॉन्सेप्ट क्लियर हो जाएंगे तुम्हारे। अब एक दिन में तो नहीं हो सकता बेटा, है ना। तो कोशिश करो अभी फॉर्मूला बेस्ड क्वेश्चंस को टारगेट करने की, कॉन्सेप्चुअल क्वेश्चंस को भी छोड़ दो तुम, है ना बेटा। The right answer to this is D. Now you must not be knowing this also, बच्चे. You must not be knowing this also from where it came. Hmm? अरे बाबा, please understand. They are asking the seepage force per unit volume, but they are asking seepage force per unit volume. I will make the entire derivation for you. Don't worry. I will make the entire derivation for you. Suppose this is the box under consideration. This is the sample under consideration, right? This is the sample under consideration. Now this is the soil. So having the A value and this is the value of the depth. So I have shown you the volume. This is the soil sample under consideration, having the A as area and Z as the depth, right? At the bottom of the above soil, the seepage pressure. If I consider the bottom part of this soil, if I consider the bottom part, just say this, at the bottom of the soil sample, at the bottom of the soil sample, the seepage pressure is the seepage pressure. How do we write it? What is the seepage pressure at the bottom of this? This is given by gamma W into H. Gamma W into H. Where H is what? Where H is what? I have told you so many times. This is the seepage head. H is the seepage head. Right? I am doing the entire derivation for you people. So this is the seepage head. Just to make it correct also. This is the seepage head. Right? Now, second point to be remembered is, now this is at the bottom of this soil, right? If I consider, if I want to correct it, this can also be written as gamma W into I into Z, because H is equal to what? H is equal to what? IZ, where I is the hydraulic gradient. Can I write this as like this? Can I write this one as this? Yes, we can write this, right? Now, seepage force is equal to what? Seepage force. This force can be given by, what is the formula for the force? Pressure into the area. The pressure into the area. Now, what is the value of the pressure? What is the value of the pressure? Now, this formula will come out to be, this is the pressure, this gamma W into I into Z into A. Now, this Z into A is actually what your volume. This Z into A is actually what your volume. So what is the seepage force? What is the seepage force when considered with the volume? This becomes your gamma W into I. So this becomes your formula for seepage force per unit volume. Seepage force per unit volume. Is it clear to everyone? Is it clear to everyone this formula? So what is the right answer for this? What is the right answer for this? Who is going to tell me the right answer for this? Say this here. The right answer for this is D. The right answer for this is D. Is it clear to everyone? Is it clear to everyone? Very good. So let us move to the last question of today's session. Let us move to the last question of the today's session, right? Okay. This is the last conceptual question. Solve it. This is the last question of today's session. Solve it properly. I want you to answer this. I want you to answer this. No MSQ. This is MCQ only. This is MCQ only. Very good, Bhageshri. Very good, Nikhil. Very good. So this is actually what, please understand, I have given this here in the class already. Piping in the soil occurs when effective pressure becomes zero. Now when the piping occurs, in order to make the piping happen, the effective pressure at exit is zero, right? This is more common in sand and gravel. This is more common in gravels, right? So, not the gravels, and this is more common in the silt, sand and silt. You should write the sand and silt rather than the gravel. Sand and silt. So this is about the piping. This is it about the piping. So effective pressure at the exit becomes zero in the case of the piping. Is it clear to everyone? Is it clear to everyone? See, we applied around 23 questions. We applied around 23 questions in around. Yes. Yes. Nikhil, please understand. Today we applied around 23 questions in just a span of around 2 hours. If I can make you understand everything, I can explain you everything, and I can apply 23 questions in just 2 hours. You can also apply 50 questions by giving 3 hours, because you don't have to explain it to anyone, right? So just Vivek Raj, tomorrow I'll try to cover the consolidation as well as foundation, right? Since we do not have all the time slots with us, we just have one more time slot. I will try to cover entire foundation engineering tomorrow, and with that I will also bring some questions of the consolidation, right? So, okay. So, this is it for today's session, bache. All of you, I expect all of you to do at least 50 questions by tomorrow. When I'll be coming back to the class tomorrow, I'll be asking you what were the number of questions you applied last night, okay? So, on this note, we'll meet Tarzagi tomorrow. Okay? Now, this is it for this session, bache. I expect all of you to do 50 questions for me, for you, and for the GATE examination. And I wish all of you a very good luck for the coming day and the coming session. And please join the tomorrow session sharp at the 7 p.m. I'll bring the questions of the foundation engineering for you people, right? Love this session, sir. Okay, bache. I love teaching you as well. Okay. Now, this is it about this session. God bless you all. Do take care of yourself. Hoping to see you tomorrow again. Bye-bye, everyone. Just God bless you. Bye-bye. God bless you, bache.
Hello students, thank you so much for watching this session. We hope you enjoyed this session a lot, and there are many more sessions to go.
So do like, share and subscribe to our YouTube channel, and this GATE score booster will definitely boost your score. So thank you once again.
Hello students, thank you so much for watching.